Assalamualaikum and hello guys. So today our group going to presenting about a water treatment plan. So the water treatment plan that our group choose is KURITA Water SDN BHD. KURITA Water SDN BHD was actually one of the facility of KURITA Water industry that was based at Japan. During the 1950s, KURITA Water Industry expanded the portfolio and started with the water treatment facility business, chemical cleaning business, and maintenance service worldwide. In her second decade, the 1960s, KURITA Water Industry entered the process treatment market, especially in the pulp and paper, petrochemical and steel industry. Since the mid of 1970 till now, KURITA Water Industry established 40 overseas subsidiaries and affiliated. One of them is at Malaysia, that was established on 14 February 1994 at Kulai, Johor Bahru. They have been serving a diverse customer base in Malaysia with innovative and value-based product, often embodying a philosophy of reuse and optimizing into their solution. KURITA Water Malaysia is strongly supported by the activity of an advanced team of technical experts based out of Singapore, which engage in R&D activity catering specifically to the water needs of the Southeast Asian region. So now that we move to the first process for the water treatment plant, which is water intake. The water for water treatment plant is taken at the nearest local river, lake and reservoir. The purpose of an intake system is to reliably deliver an adequate quantity of water for the best available quality. An intake system must possess a high degree of reliability and be able to supply the quantity of water demand by a water utility under the most adverse condition. For a large capacity of water treatment plant, detailed survey including hydraulic calculation, mapping, pumping station, source of the water supply and other scope have to be done for designing the intake plan.
Assalamualaikum and hi, my name is Nur Anissa Asma binti Besar. So now we talk about aeration of the KURITA company. Aeration is often the first major process at the treatment plant. Aeration brings water and air in close contact in order to remove dissolved gases, such as carbon dioxide and oxidized dissolved metals. During aeration, constituents are removed or modified before they can interfere with the treatment process. Constituents commonly affected by aeration are volatile organic chemicals such as benzene, which can be found in gasoline, ammonia, chlorine, carbon dioxide, hydrogen sulfide, methane, iron, and manganese. This is the aerator that KURITA company use. The surface aerator pushes water from under the water surface up into the air. Then, the droplets fall back into the water, mixing in oxygen. The jets of water break the surface with varying degree of forces. Aeration brings water and air in close contact by exposing drops or thin sheets of water to the air or by introducing small bubbles of air, and then letting them rise through the water. The scrubbing process caused by the turbulence of aeration physically removes dissolved gases from solution and allows them to escape into the surrounding air. Aeration also helps remove dissolved metals through oxidation, the chemical combination of oxygen from the air with certain undesirable metals in the water. Once oxidized, these chemicals fall out of solution and become particles in the water and can be removed by filtration or flotation. The efficiency of aeration depends on the amount of surface contact between air and water, which is controlled primarily by the size of the water drop or air bubble. The next process is coagulation. For the coagulation process, KURITA company proposed a water treatment chemical KURITA ZE, to promote the coagulation effect of the chemicals used at the plant. Coagulation is a process used to neutralize charges and form a gelatinous mass to trap particles, thus forming a mass large enough to settle or be trapped in the filter. Coagulation destabilizes the particles' charges. Coagulants with charges opposite to those of the suspended solids are added to the water to neutralize the negative charges on dispersed non-settable solids such as clay and organic substance. Once the charge is neutralized, the small suspended particles are capable of sticking together. The slightly larger particles formed through this process are called microflocs and are still too small to be visible to the naked eyes. A high-energy rapid mix to properly disperse the coagulant and promote particle collisions is needed to achieve good coagulation and formation of the microflocs. Overmixing does not affect coagulation, but insufficient mixing will leave this step incomplete. Proper contact time in the rapid mix chamber is typically 1 to 3 minutes.
Hi and Assalamualaikum. My name is Nusra Zahira binti Abdul Razak. My ID number is AB19178. In this video, I want to explain about flocculation, sedimentation and filtration. First, I will explain about flocculation process. Flocculation process is a process where the particles stick together to make a flux due to the chemical reactions from coagulation process. The flocculation is a slow mixing process because it relies on turbulence to form a flux. There are two types of flocculation, which is mechanical flocculation and hydraulic flocculation. For KURITA water, it uses the hydraulic flocculation because it is the most simple to construct and operate the process. Next process is sedimentation process. The sedimentation process is a process where the suspended material from flocculation process to be removed. The sedimentation process only depends on gravity. There are three types of sedimentation process, which is type 1, type 2, and type 3. Type 1 is the particles tend to settle as individual particles without being collided with other particles. There are no change in size and shape in type 1 because of it. Type 2 of sedimentation is where the particles in the middle of flocculate. It happened when the particles started to change to the different size and shape. The last type is type 3. This type is where the particles has changed into a bigger size and shape of the particles. It will sink to the bottom of the tank. This happened because of the higher concentration of the particles. It causes to form a layer called blanket at the bottom of the next process is filtration process. The water from sedimentation process will pass through the filter that consists of sand. The floc and impurities that are bigger than the sand will stuck and produce the clean water. There are two types of filtration, which is pressure filter system and gravity filter system. Pressure filter system is where the water is passing under a high pressure through a closed cylinder. In gravity filter system, there are two types of filter, which is rapid sand filter and slow sand filter. The rapid sand filter increase by increasing of the size sand grain. There are two operations in rapid sand filter, which is filtering and backwashing mode. Filtering mode, water is applied to the top of the filter and flows downward. For backwashing mode, it used to clean the rapid filter so that it will become more efficient. The water cleans the filter and erodes the solid from filter mineral, expand the filter bed and transport the solid towards the backwash through. Slow sand filter is where the water passes through the sand slowly.
My name is Mama Afif bin Adnan. My matric number AB19147. Let's talk about disinfection. Disinfection is the process which involves the elimination of most pathogenic microorganisms on inanimate objects. Chemicals used in disinfection are called disinfectant. Different disinfectants have different target range. Not all disinfectant can kill all microorganisms. And the important thing is to minimize number of organisms in the population worldwide. The method of disinfection is used internationally for the safety of humans to decrease the scale of transmission of disease. And the common use aldehyde, alcohol, and phenol, which is alcohol. 70 aqueous alcohol is more effective at microbial killing. 70% ethyl alcohol is used as antiseptic on skin. Water distribution. Water distribution system consists of an interconnected series of components. They include pipe, storage facilities, and components that convey drinking water. Public water system depend on distribution system to provide an uninterrupted supply of pressurized, safe drinking water to all consumers. Distribution system may carry water from either the treatment plant to the consumer and the source to consumer when treatment is absent. Distribution systems span almost 1 million miles in the United States. They represent the vast majority of physical infrastructure of water supplies. Distribution system where the tier can pose intermittent or persistent health risks. Water quality and the distribution system. New pipes are added to distribution system as development occur. The addition results in a wide variation in pipe size, material, method of construction. And then last thing, my suggestion to reduce water usage is install low flow features. Save water. It can save water and money by installing low flow toilet, shower head, and faucet for a household of 4 people. This means over 100,000 liters of water saved per year. Second, turn off the tap while washing your face, brushing your teeth, and shaving. And last, save leftover ice. Have leftover ice in a bowl or cup. Instead of dumping in the sink, let it melt and use the water to hydrate your plant or drink it yourself. Thank you.